Hello everyone, good afternoon. I'm Ross Wilson. This is the first Fiat IFTA event that I've been to, so I hope to be invited back for future ones, but we'll see how well this talk goes and then maybe I get invited back. I am Ross Wilson. I'm lead architect in Archives Technology and Services at the BBC. As the name suggests, we are the archive department. We are responsible for archiving of BBC content. That's not just kind of digital, we've also got extensive physical holdings as well. But what you might not know is that we do a archive at the point of delivery methodology to our archiving. So we're also the front door for content coming into the BBC for our file-based delivery and live capture into the archives. Now, I'm not going to talk through every single one of these, nor do I expect you to read each one of these, but this is just to kind of set out the scale problem. So across the BBC, and particularly in BBC archives, we've got extensive data sources, and these range from your traditional MAM that you'll be familiar with. We've also got on here a split between AV and radio. So there are radio archiving solutions here, of which we have 2 of those. We then also have more PAM or production asset management solutions as well. So particularly around news, so managing newsroom content. System down at the bottom right there is an older version of our Jupyter newsroom solution, which itself has an archiving function built into that. And you may notice if you glance closely, there are spreadsheets down in the bottom left. We manage sports rights. You see there's a BBC Radio just web server with kind of text files. So it is a broad ecosystem. Each of these has a different ontology, a different, well, we certainly don't have a kind of a unified vocabulary for a lot of this stuff. The way that we kind of think and refer to content varies depending on which system you might be looking into. In just one of those systems, so that's the system in the top left, we've got 75 years worth of content. That's 75 years if you were to play each item end to end. The system, which is kind of on near the right there at the top that says search to BBC archives, this is called Archive Search. The system that I'm going to be talking through in a minute is the successor to Archive Search. But what Archive Search tries to do, and does pretty well, is it has ingested 40 million assets from all these different data sources, certainly not all of them, but a lot of them, and it makes those accessible in a web browser in a somewhat standardized format. One of the problems with that is that it is an aggregator of archive material, and the new system, and I'll talk about that in a second, has got some key advantages that kind of makes it a bit more accessible for users. And then finally, what isn't on this screen, although the metadata describes, are the physical holdings that we have as well across tens of physical sites around the UK. So, I talked about Archive Search. Now I'm going to introduce BBC Library. This is the successor to Archive Search. And ultimately, and we've got some screenshots in a minute, ultimately what this is again an aggregator and a way to manage and discover content across the BBC archive. The key kind of elevator pitch, I suppose, is that our current methodology has been asset-centric. So that's kind of referring to things as assets, individual items. Our new way of thinking about this is a content-centric approach. So this is the idea of aggregating together multiple pieces of media, metadata, physical holdings, that kind of thing, under the logical piece of content. And it might be that you've got multiple renditions, multiple recordings, that kind of thing, that all relate to an episode of EastEnders or Doctor Who, that kind of thing. So this has a key advantage really here in terms of accessing archive material kind of as a end user would think about the content. They think in terms of episodes, they think in terms of raw material for a particular episode or series or brand. And we hope that that's going to allow, or provide an improvement at least, in terms of searching for content, discoverability of content if you're not quite sure what it is that you're searching for. There are 4 key contexts on this, and we're not going to get too kind of architectural and dig into the architectural principles here, but those 4 coloured boxes are the different contexts here. We've got a receipt context. We refer to that as our front door into the archive, of which we've got just listed there 4 kind of key categories of sources. File-based delivery, like I said, all content that comes into the BBC comes through our department, and we archive at the point of delivery. We've got live broadcast capture, effectively the opposite of file-based delivery. Internal content, so that's the PAMs, the MAMs, the spreadsheets, the text files, that kind of thing. And then finally, we've got the legacy archive collections, which incorporates the physical holdings as well as those material that's already held in the archive, be it on-premise or in the cloud. In that receipt context, we've got various functions. Acceptance and provenance are two key ones. This is a place for us to facilitate things like fixity checks. Charlie yesterday talked about C2PA from a provenance perspective. There's an opportunity here, not implemented yet, but we're interested in how we could incorporate C2PA into that front door process for when content's coming into the archive, validate that kind of chain of custody of where the content came from. Things then split into a metadata and a media context. It's quite obvious which ones those are. In the media context at the bottom there, this is where we're storing the media. This is a place for us to look into technical metadata, generate proxies, again, do those kind of fixity checks, not just on the way in, but on an ongoing basis. The metadata context, though, is I think where it's really interesting. You'll see on here that the phrase data lake has made it onto the diagram. This is kind of our raw storage, if you will. So all those different 20 sources, they get aggregated in, they get ingested in to the metadata data lake, and then we go through a medallion processing stage. We're not going to get into the kind of the data engineering, data science of that, but you can see that each one kind of successfully builds upon the next. We extract the data, we clean and remodel the data, and then we match and aggregate. And it's that matching which does the pivot from asset-centric thinking to content-centric thinking. One of the sources, in fact, is our audience-facing metadata mechanism, the same thing that powers the metadata you see on iPlayer or BBC Sounds, that kind of thing. And that matching is being done by, currently, matching based on identifiers. There's many different types of identifiers, as I'm sure you'll be aware in your own organizations. So we have program numbers and audience-facing publication numbers. Fortunately, a lot of the metadata has significant overlaps of those identifiers, and that allows us to say, this is the same as that, and then that's the same as this. And collectively, you end up with this content-centric view of the world. On the right there, we've got a discovery context. This is kind of the interface, if you will, because we've done all this work in the metadata context. We've built this aggregated store of nice content-centric records, and we've got the media context, which has got the media reference there. But how do you actually expose this to users? Where do you get the value from that? And that's in this discovery context. A screenshot in a second, which shows off our new search application, the version 1 release, which is going out in 3 weeks' time to a select kind of 200 users, and it'll be expanded out from there as new features and so on come along. A key point to make is the metadata admin functionality. So we're currently working on this edit interface, which is going to be, again, a web-based interface for archivists, admins, those kind of people, to effectively have the human-in-the-loop review. So this is a place to make changes to edit metadata, also supplement metadata, and when we start talking about some of the machine learning enrichment, which we'll talk about in a bit, it's a place to review those, edit those, and approve the use of those. There's a nice little screenshot of BBC Library Search. Looks a bit like probably what you'd expect from a web-based archive access tool. A player on the right, search results in the middle, and some faceted searches or filters down the left-hand side there. Like I said, this is our version 1, and we're looking to get feature parity with that current archive search solution that this will replace. A key part that I wanted to talk about, I think most relevant to the use of AI and ML in archives, and we've heard about it early today and yesterday, is semantic search. Semantic search is something that we've been investing in, we've been looking into. It's probably unlikely to make it into that very first V1 release to the first 200 users, but we do have a working solution that we're going to expand upon. But why do we care about semantic search? What's the value here? So the key one, you've probably got this from the presentations in the last 2 days or so, is around enhanced relevancy, and a key bit there is the ambiguity element. So we had a really good example a while back where we were given a demo. Someone searched for riverbank, and if you did a keyword search, people were getting financial institutions come back in their search results, and there was no kind of understanding that the word bank is ambiguous. So when we ran that then through a semantic search set of search results, we did indeed get natural history unit content come through up front and centre. Less reliance on curated archive description fields. This isn't to say replace that process, but it means that we can enhance the data that we've got. It means that we can process a lot more items and far beyond what we have the human capacity to be able to sit there and kind of type out and have those humans predict what kind of keywords might someone search for to find this piece of content. Uncover hidden or poorly tagged content. This is a key one. We've got an awful lot of content, particularly radio content, for which during the production process, we don't get an awful lot of metadata. We don't get kind of rich contributor information. If you're lucky, you might get a short synopsis. Typically, that's a repeated synopsis. So if you've got like a Greg James radio show, typically they don't write out a synopsis for each episode. You'll just have kind of a stock synopsis for that year's worth of programs. So radio and audio programs particularly, we typically have less metadata than we would in the case of TV programs. Transcripts and object detection is going to be a key part of the second part of my talk, so we'll get to that then. Multilingual. We were talking this morning about Welsh to English and English to Welsh and other languages. We've got some examples of where we're using a multilingual ML model, which is allowing you to discover content that matches your semantic query, but it's in a different language. And typically, if you're using keyword search, you wouldn't get those results back. And finally, you don't need to be a subject matter expert to get certain search results back. So you can imagine, and we do see this, where we've got natural history unit content, we've got assets in the archive that use quite specialist terms for either place names or animals, that kind of thing. And we've found that using semantic search has allowed users who maybe aren't familiar with that exact species name to discover content that they otherwise wouldn't have found were just using keyword searching. Very briefly on this one then, so this is the data lifecycle for what powers that semantic search experience. Media content catalog is the name that we give to that data processing, that data engineering step that looked at the medallion processing. It builds out that big content-centric database of assets that have been aggregated and squashed together. Data flows out of that into our search indexing pipeline, where we've got a process that we've dubbed leanification. So the media content catalog gives us very rich, nested information, not necessarily optimized for loading into a search engine. Makes the queries quite complex, and there's performance considerations there as well. So we flatten down that data to just what is needed to power the searching experience. We don't throw away the data. Once a user has selected a search result, that's when that richness then comes back. Indexing, we're using OpenSearch, which is the kind of a version of Elasticsearch to power our search experience. And we're generating vector embeddings. Currently, we're doing that within OpenSearch, and maybe in a bit there's some mention of plans to improve that or some performance considerations that we've got around that. This is a quick how. I'm not going to get into kind of choosing ML models or anything like that. Like I said, we're quite early in our journey around this use of semantic search, choice of ML models, that kind of thing. I'm particularly interested in joining up the conversations that we've had today around kind of Welsh ML models and things like that. For now, we're using an open source off-the-shelf multilingual model, of which was trained on 50 languages. Unfortunately, Welsh was not one of them. So it'd be very interesting to see what we can do around plugging in a better model for that content. Here's a demo of multilingual search. So here we've got a search for healthcare in English. You see so the results 1 and 2 seem reasonable. Hopping aboard the hospital train, basic elderly NHS care alarming. The third result is interesting. for a start, it doesn't contain the word healthcare, although it does contain the word health. But what you see here is a Persian program. The synopsis, which is matched semantically, if you translate that into English, is talking about a health and wellness topic, which again doesn't contain the word healthcare, but does talk about health and wellness. And semantically, that matches a search for healthcare, and therefore it has come back in the results. Now you can imagine that's both good, but also provides a challenge. It's good in the sense that it's more results coming back, and it's a challenge because there's more results coming back. The user may not understand Persian. So there's kind of an interesting product and user experience challenge there. Like more search results that are relevant isn't necessarily a good thing right out the gate. There's some considerations around how you actually present that to users. Do you need to offer additional filters to say, I don't speak, or these are the languages that I do speak, and please optimize the search results for those. I mentioned around, currently we're generating semantic search vector embeddings in OpenSearch. What we'd like to do is switch that over, and shift left is the phrase that we're using here. So you can imagine this pipeline of, you saw that receipt context, then you saw that metadata processing context, and then you saw the discovery. Think of that as like steps 1, 2, and 3. What we'd like to do is shift the generation of vector embeddings left, such that it becomes a first-class piece of data. It's not just kind of kicked out to the edge in that search application. We kind of bring it in and treat it as very important, rich archive data that we can ourselves archive, version over time, and make sure that we've got good provenance, good audit history, all the things you'd expect from an archive. Why should the semantic search vector embeddings be any different? Just a quick summary then on the things that we're doing with semantic search, and then we'll move on to content enrichment. And we've got some, hopefully, interesting demos of what we're doing with media and AI and ML for those. So, indexing of content-centric records, that's the kind of the key pivot that we're making here. That's the bet that we're making to move from asset-centric to content-centric. And one of the key points there in terms of the human actions or the human impact is there's less reliance on that kind of very heavy keyword curation, kind of archivists and researchers kind of predicting what kind of keywords might someone search for, and therefore I need to stuff into a archive description field. Multilingual retrieval, if you do a simple keyword search, unless you put in the keyword in those relevant languages, you won't get those search results. I've put on there that current model that we chose just to kind of get out of the gate was trained on 50 languages. It's a big list of kind of the more common languages, but Welsh, Scottish Gaelic and Irish Gaelic underrepresented in popular ML models, and certainly in the model that we've chosen. We are and have implemented a feedback mechanism. So this is a simple contact form on the top of the page for users to report bad search results where there's potentially biases. Those can get flagged and we can review those. When we start getting into the weeds of fine training models, that's where we're going to be able to use some of that feedback and hopefully make corrections and improve the search results there. Shifting left, like I said, make this a kind of a more first-class concept. Don't just generate them in the search application right at the edge. Make them that key piece of data that gets archived along with the media, along with the metadata. It itself is metadata. And then finally, as I was just saying around, we're interested in ML models that are trained on the Welsh language. There's naturally going to be a need to evolve models over time. This isn't just a one, you pick your model and that's it for the next 10 years. New model versions will come out, entirely different models we might want to try. We might want to A/B test them and evaluate them side by side. So we're thinking about that in terms of how do you roll out new model changes. If you've got 40 million assets and you need to regenerate all those vector embeddings, what does that look like? Fortunately, we're very good at keeping track of media. We've got storage management systems that can do that. That's why we want to shift left and kind of treat the vector embeddings like we would media, do fixity checks on them, that kind of thing. So that was semantic search stuff. now content enrichment stuff. There's various types of content enrichment that we are either doing already or have plans to do. Semantic search embeddings is obviously one of them we talked about. Transcripts, I think every talk, the last 2 days have been involving transcripts and speech to text. Given that we're the front door of content coming into the BBC for file-based deliveries, we're also the front door for subtitle files coming into the BBC as well. So fortunately, a lot of the content that does come in already has subtitles that have been kind of created by humans. But there's also a lot of content that comes in, primarily live content, that doesn't have subtitles. Radio content doesn't have subtitles, sadly. So there is still a need for text representation of content. So speech to text has a place to a part to play there. Generating new media assets. These are kind of your traditional media asset management kind of functionalities here. So generating browser proxies, thumbnails, sprite sheets, and audio waveforms. Although we did hear yesterday around the challenges of even generating thumbnails can have a challenge. If you generate a thumbnail every second, there are challenges with that. Are there opportunities to use AI and ML to do a smarter generation of thumbnails, scene and shot change detection, which is this next point. Chapter markers and scene detection. We've got some examples of what we're doing with that. Ontologies has been a common running theme here. There's a BBC ontology called BBC Things. You can go to bbc.co.uk/things. I'm not sure if it's a great name, but BBC Things describes various things, entities, places, contributors, that kind of thing. And we are integrating BBC Things metadata into BBC Library such that over time, the aim is for all content to have a BBC passport, which is an internal concept. It's basically a metadata record for a piece of content that relates to BBC Things entities. And at that point, you've got a kind of a shared vocabulary to refer to things. You can hop between content more easily, particularly around contributors, sentiment, and genres. If everyone has a shared set of terminology, that benefits. That's one of the challenges at the moment of having those 20 distinct data sources. There's a different term for each concept. Face detection and recognition. We've seen demos over the last 2 days. We've got a demo as well to show what we're doing with that, particularly interesting around multimodal face detection. So we'll talk about that. Very briefly, a bit about orchestration. Similar diagram to before. This is a mechanism that we're building out using AWS technology, step functions, that allows you to plug in and do various bits of processing against media. The key bit to call out here is that we're using Whisper at the moment as our speech-to-text engine. That's provided internally by a separate team, hosted in our own cloud, but provided to us as a kind of a basic input-output. Give us your media, here's your transcripts. That's the end of that kind of transaction. We're still responsible for storing that, referencing that, holding it for the long term. And that media content catalog element there has a very interesting capability, which is this selection. So selection capability. This allows archivists to go in and select subsets of the BBC archive and say, I'd like to run this content through speech to text. In the last quarter, we did 100,000 hours of speech to text content through Whisper. We're getting really good results. We also have an in-house speech to text engine called Caldi, which we've been using, and AWS Transcribe as well as a managed service. These are all kind of pluggable engines that we can plug in. Longer term, we're having conversations with departments and teams outside of BBC archives. We like to go and talk around the business. One of them is our news team, the news PAM, Jupiter, I referred to earlier. They are very interested in when news content effectively leaves their ownership and kind of effectively gets archived. Then if we've done various types of enrichment, how can they benefit from that? How can they, in the newsroom management system, how can they benefit from semantic search and the vector embeddings that we've generated, the transcripts we've generated, the face detection results, that kind of thing. So we're looking at how we can share this data around the organisation and not just kind of keep it within the archive. Chapterization. This is a demo that we ran, and we've got some tooling in place now to do this, around generating chapters automatically that are time-coded. This is a podcast, this is a BBC Sounds podcast around Disneyland and Walt Disney. And you can see here that not only have we identified the various chapters, which I suppose is similar to the kind of the ad insertion talk from earlier, we've also got an AI-generated description of each topic. So you can imagine this could be useful as well, not only for just presenting to users. The BBC is already doing a trial that's in production right now. So if you go to the BBC Sounds app, there are certain podcasts and audio shows that you can watch that have had speech-to-text transcripts auto-generated, and then the ability to have them in chapters, have it kind of sliced into various chapters. There's a team looking into that as well. We saw that, I guess, most recently at the Olympics. I think it's probably the most well-known example of this, where you might have like a 12-hour live stream. Once that gets turned into a video-on-demand asset, that's quite tricky to kind of navigate through. Turn it into chapters for each sporting event has a lot of value there. This is object recognition. So this is a screenshot from The Apprentice, and you can see in here that it's identified a bunch of physical entities in the picture. You can imagine a world where these physical entities are BBC Things ontology items, and therefore you can kind of navigate through. If you're an archivist and you're particularly interested in shots containing a whiteboard, you'd be able to search for and find this content. Crucially, each of these points is time-coded as well. So rather than just returning back this episode of The Apprentice, it's an hour long, we can take users to that exact point. So there's some value here in object recognition and object detection. A key kind of interesting point, and there's a slide talking about this in a minute, is show rate. So up in that top corner screenshot. This is in this example, the percentage of suits. So if you get people wearing a suit in The Apprentice, which is something a lot of them wear, that appears 4.4% of the program. So there's an interesting kind of analytical way to think about these kind of detection results. Here we've got kind of OCRing of in-video text recognition, particularly for our news output, where we've got kind of baked-in graphics. It might be, and it would be superior really, to have an archive of both the clean feed and the dirty feed that's got embedded graphics. Quite often operationally, that's tricky to achieve. So you can imagine there's a lot of value here in being able to identify and recognize on-screen graphics, provides extra context that itself can be useful for searching. Another example here of object recognition. Here we've got detection of alcohol. This is another shot from The Apprentice, particularly in our BBC Studios commercial arm of the BBC, which part of their function is monetizing content, selling content, depending on which territory they're selling content to. Different territories have got different opinions on and different rules around, for example, alcohol in content. So having metadata that is time-coded to say there's alcohol in this scene, there's value there for them when it comes to selling the content. However, it is fallible. It could be a gin and tonic in that water bottle, but probably not. It was very confident though, it was 93.9% sure that there's alcohol in that scene. The multimodal aspect that I talked about earlier, so this is where we've got, there's kind of three screenshots here. It's on this slide. On the left, we've got quite a nice publication photo that we typically get. It's the kind of thing that you would see on billboards or on iPlayer, that kind of thing, editorialized. This is a photo of Alan Sugar. We've ingested this into this demo application. This is Amazon's Media to Cloud solution, which is effectively a thin layer on top of the managed services you get from AWS. So we ingested in this photo of Alan Sugar. We then tagged that with Alan Sugar, the BBC Things entity. So you can see that in the bottom left screenshot. So there's a big ID for that face, and it's then got a human identity associated with it. And then on the right, we've got a video. This is an episode of The Apprentice, and you can see that based on the training for the photo, it is now able to identify Alan Sugar in the video. So depending on, again, kind of an analytical way of approaching this, if you've got, say, thousands, tens of thousands of hours of content of, say, EastEnders, training maybe just, or tagging up, I should say, maybe 20 photos of cast members of EastEnders could have quite a large hit rate in terms of identifying those faces and putting names to those faces in tens of thousands of hours of content. This is kind of a nod to that concept. This is kind of the human in the loop element of how we can use this analytical way of prioritizing that human effort. So rather than just having the AI run away and present, here's 100,000 faces, where do you start when we're being asked to have people tag those up and stick an identity against those? If we can use things like the show rate, in this case, this is one of the contestants again in The Apprentice. In just this episode alone, he appears 225 times, that's 4% of the program, and he's there from the start of the program to the very end of the program. You can imagine that stretched over a segment of the archive or the entire archive. If this person appears even in 1% of the archive, over 40 million assets, that adds up. So just tagging that face, again, you can kind of hit a good amount of the archive with an identity there for that face. Scene detection. So we've got and have had in the past various experiments and investigations into scene detection. A few years ago, BBC iPlayer, the back-end team that powers BBC iPlayer, did some experiments. So when you watch something and you get kind of the autoplay to advance on to the next episode, they did some work using AI and ML to detect when did a credit start, and therefore you can offer up that auto-playing or that next play trigger earlier, because people don't typically want to sit and watch 45 seconds of credits. They'll probably want to skip over those. And again, this is a capability that we've got demoed here. So you get on the left a kind of human readable output. You also get a description of the scene. In this case, the scene is the credits on a black screen, so it's not the most interesting. On the right, though, you get a machine readable output, which again can be used in a search application, for example, but it can also be used in audience-facing applications like iPlayer, for example. And then finally, it's not just digitized audio and AV that we're thinking about. This is a photo or a scan of a digitized catalog record. And here we can see, after run through an AI ML engine, we were able to turn that into machine readable JSON. So that is, hopefully, this is the start of a project, but hopefully this exposes catalog records and metadata that's currently locked in boxes and filing cabinets. We can bring this into a search application. So in summary, we're helping to unlock discovery of surfacing that undiscovered radio, TV, and physical holdings. Very important that we've got human in the loop for that kind of accuracy. A phrase that we've been using is this: AI proposes, archivists validate, as a phrase. Accessibility for all, generating transcripts to go alongside those subtitles. There's a lot of value for deaf, visually impaired, non-English speaking audiences. And that kind of workflow improvement that we've got, AI reducing ingest and cataloging time, freeing staff to focus on valuable activity that only humans can do, managing rights, managing curation, that kind of thing. That's me done. Thank you.